And suddenly David Anthony's name is David Anthony Soldiers. I'm not sure how that happened or why that happened, but as long as I know who you really are, that's all I care about. All right, we were talking about nucleic acids yesterday. And we talked about the subunits that they're made of. So we showed you a picture of a phosphate group. We showed you pictures, but we never got to actually talking about these things, and there's some things you need to write down. So phosphate group, this is the regular, whoa. All right, can't get back much farther than that. Unit 1, page 1. Let's try this again. So phosphate group. Phosphate group is the regular old PO4 3 minus that we talked about way back when we were doing polyatomic ions. Pentose sugar, 5-carbon sugar. So ribose is in RNA. And actually the R for ribose is the R for RNA because RNA stands for ribonucleic acid. And deoxyribose is in DNA. And again, D is where DNA comes from because this stands for deoxyribonucleic acid. And the only difference between ribose and deoxyribose, D means without. So deoxyribose is ribose minus, I should write the word so you don't think that's a dash. Never mind writing the word. It doesn't want to cooperate. So let's try it this way. DNA is ribose missing and oxygen, NO. So here's the picture I wanted to show you. And if I'm screen sharing right, you should be seeing a picture of glucose, fructose, galactose, you know, like a long time ago, and a galactose far, far away. Deoxyribose, ribose. If you're not seeing those, you should let me know, but I'm pretty sure you are. Now, first of all, pentose versus hexose sugars. These are the sugars we've talked about, except for, I don't remember if we talked about galactose or not, but I know we talked about glucose. We've talked about glucose a lot. And I never told you this, but these are hexose sugars. Hex meaning 6, ose meaning sugars. So they're made of 6 carbons. So every point that doesn't have something else is a carbon. So that's a carbon, 1. I'm sorry, I didn't want to write C, I wanted to count. So this is 1, 2, 3, 4, 5, and there's the 6th one right there. So that's a hexose sugar or a 6-carbon sugar. This point is not a sugar because this is where the oxygen goes. In fact, a lot of places write the oxygen right there instead of up, because up makes it look like it's attached, like this OH was attached. So fructose, fruit sugar, if you remember that, again, the O can go right there. So that's 1, and then every point of the figure is a carbon. So 1, 2, 3, 4, 5, 6. Hexose sugar. 1, 2, 3, 4, 5, 6 for galactose. So these are hexose sugars. That's why ribose, that's why I specify pentose sugar for ribose and deoxyribose, because if we look at these, again, the O is goes right there. It's not a carbon. We have 1, 2, 3, 4, 5 carbons. So it's a pent. 5-ose, a 5 sugar or a 5 carbon sugar. OSE ending means sugar. Remember that. And we get the same count with deoxyribose. So it's a pentose sugar in DNA and RNA. That's a key point. And let me clear up some of this clutter here. And now I want you to notice ribose has OH and OH. Deoxyribose is missing this H right here. This part matches. This part matches. The 5 sugars match, or 5 carbons match. This is going to be too cluttered. This matches. Everything, if you kept going, except it'd be such a mess you couldn't see anything. Everything, if you kept going, matches except for this part right here. H versus OH. That is the only difference between deoxyribose and ribose. What difference does that make in, why the cell needs one DNA to have deoxyribose and RNA to have ribose? I don't know what difference it makes, but the cell does it that way and only that way, and it won't work the other way. So there has to be a difference of some sort, because frankly, in a lot of the nucleotides, all of them except thymine and uracil, the only difference between RNA cytosine and DNA cytosine is that O or not O. So it's an important difference. Why? What makes it important? I don't know, but it is. Okay, so here's the thing. There's what I was just talking about, RNA versus DNA, cytosine or guanine. And these two always pair. Cytosine always pairs with guanine, DNA or RNA. I think I'm going to do that slightly different. Just a second here. So cytosine and guanine always pair RNA and DNA. Adenine and thymine pair in DNA, and adenine and uracil pair in RNA. Now, having said that, DNA is always double-stranded, so DNA is always pairing. RNA is single-stranded, but sometimes it matches up with another RNA or a DNA. So make sure you get that single-stranded versus double-stranded. We'll talk more about it. I haven't said enough about that yet. It's probably like out of the clear blue. Most of this is out of the clear blue. That's why it's so hard for people to keep straight for the first while. All right, so there are subgroups. There are 3 subgroups of nucleic acid. And these subgroups are substantially different in some ways. They have things in common, like they're made of nucleotides. They have things that are substantially different. And right at this moment, I want to start looking at those subgroups, starting with deoxyribonucleic acid, or DNA. And as we already pointed out, this is not new. It contains deoxyribose. Now, notice this. DNA is arranged into it's double-stranded, two anti-parallel strands. Now, the term anti-parallel is frequently brand new to people, juniors in high school, right now when I mention it. Unless I said it in 10th grade and it sunk in, you don't remember, you don't know what anti-parallel means. And a lot of people say, well, let's see, anti is not, so parallel is side by side, go in the same direction. So the other thing I know is perpendicular. Anti-parallel must be another term for perpendicular. No, no, no. If anti-parallel was another term for perpendicular, I would have said perpendicular. Anti-parallel is a special kind of parallel. Anti-parallel sorry for you who are red-green colorblind. Anti-parallel means parallel in opposite directions. Now, when you did lines in geometry, you probably didn't care about the direction. If you've done vectors, I don't remember when, I guess remember nothing. I don't know what grade, what class you guys do vectors in. But if you do vectors, these vectors are going in the same direction. They are parallel. If this doesn't make any sense, imagine, let's see if I can do this. Oh, let's play around a little bit here, see what we can do. So let's say I stop sharing for just a minute and start my video and make this the pinned video. All right, back up, I'm too close. So I have here a pair of arrows, or more correctly, crossbow bolts. So right now, these are more or less parallel. They both have the point on this end, and they both have the nock and the veins on this end. So parallel. These are more or less, if I could hold them straight, these are parallel. Now, if I switch one, they are still parallel, but they are pointed in the opposite directions. If we assume the direction is the way the arrow flies, the top one, the back is on the left and the point is on the right. The bottom one, the point is on the left and the nock is on the right. So this is what anti-parallel means, if I can hold them straight. Parallel in opposite directions is anti-parallel. This is regular parallel. This is perpendicular, more or less. This is anti-parallel. All right, back to the notes. Where do I need that to go? Oh, I guess I can get rid of the video too. It's gonna eat up my bandwidth. I sometimes need every bit of data that the bandwidth will carry. All right, so the two strands of DNA are parallel in the opposite direction. And this is something I was going to show you. I had a picture up and then I had to restart the computer. So just give me a second here. Well, none of these are popping up with what I want to see on them. Yeah, might have to find, wait a minute. May have to find one and show it to you tomorrow. All right, I'll just find one and show it to you tomorrow. I had it and now I can't find it. I had to restart the computer. All right, in DNA, the strands twist into a double helix. Everybody talk, I mean, sometimes double helix is used as a synonym almost for DNA and for chromosomes. So, so that's a term that you may have heard and a term that you should be familiar with. Now, what a double helix means is it is kind of, if you can imagine, if anyone still has, or your grandparents have or whatever, an actual landline phone with a cord. Can you imagine that? A cord connecting the part you talk into to the part on the wall. It used to be before wireless, before cell phones and before wireless phones that you could carry around your house, that every phone had a cord, and frequently people would put a phone with a very long cord in the kitchen so that when they were working, when women or men, but usually women, were working in the kitchen, they could be talking on the phone and walking all over the kitchen. And that cord at first would just be coiled like normal phone cords, if you've seen normal phone cords. But then after a while, it would get to the point that when they hung up, it would coil and then it would twist and make this short, fat thing. It's kind of what we mean by double helix, if that makes sense, I hope. All right, now, this is very critical, very important. What does DNA do? DNA carries instructions for every protein which the cell will ever produce. And in so doing, because of that, it controls the hereditary information of an organism. DNA carries your genetic material. Your DNA makes you what you are. Love it when that gets all crooked looking like that. Jumps to crooked. All right, so an instruction for a protein is a gene. That's all genes are. Gene with a G. Gene with a J are things, you know, that go over your legs. But that's all a gene is, an instruction for a protein. So DNA is the chemical that makes up your chromosomes. The chromosomes have your genes, and the genes are instructions for proteins. So ultimately, DNA is the hereditary material that carries the instructions for proteins or the genes that make you who you are. So this is a very, very, very important structure. All right, RNA is going to take a while, so we'll save it for next week instead of just getting a little bit into it and stopping. Don't forget that you have a quiz to take. And what else? There's something else I need to tell you. If any of you feel like you want to take an optional test like last time, you should let me know because I'm not going to get it ready if no one wants it. All right. Have a good weekend.